I'm going to present the presentation which is going to cover the polyamide product range and especially specialty polyamides and high temperature polyamides. The presentation is going to mainly cover automotive applications, but the scope of the presentation and the application is way beyond the automotive. Already it has been established and successfully used by many customers for non-automotive applications, but just to keep the presentation within the time limit, we are going to talk about a very focused area of automotive. All the guests are welcomed for the questions related to non-automotive as well, and we will try to answer the questions to our level best. So today what we have in agenda is we will briefly talk about Arkema, what is the current automotive scenario, introduction to our bio-based polyamide, that is polyamide 11, what solutions we have, and virtually we conclude the presentation with a concluding remark. Quickly talking about Arkema, these are the facts and figure about 2010. We are mainly into three markets, that is performance products, vinyl products, and industrial chemical. I am representing here the performance product group, which covers the technical polymers segment. What we have to offer in technical polymer range is the high performance polyamides, that is polyamide 11, polyamide 12, and PPA based high temperature nylon. We do have a high performance elastomers which are marketed under the brand name of Paybacks. We do have thermal adhesives and functional polyolefins. The ultimate inconvenient truth is that the current situation is that the cities are getting more and more polluted due to the more and more number of cars and CO2 emission. As we are getting more and more number of vehicles coming on the road, the traffic congestion is the biggest problem, and we all are facing the same every day. Getting from say 5 kilometers, which could be covered in 5 minutes, we are spending maybe more than 1 hour, and virtually all this situation is resulted into the CO2 emission and global warming. So just to talk about the CO2 emission, the left hand side shows the overall CO2 emissions. As you can see, China is leading the chart with the huge capacity for the car production and automotive production. And on the right hand side, what we want to target is the reducing the carbon footprint, and there are different ways to do it. One of the ways is to use the raw material, maybe bio-based, but of course it is not contributing significantly. It's just 4.1%. What is a key thing which we could do is use an alternative vehicle, but that is yet to be tested and yet to be proved. There can be an engine technology which can be referred, but then of course it is not plastic. As a plastic engineer, it is not my specialty. Weight reduction, which could be bought by the replacement of metals or with a lighter material, and of course lastly with the new propelling energy sources. This is just for the reference what are the current regulating and CO2 emission norms for all the people here. Right now the global reference is Euro 5 and Euro 6, and soon it will be followed in the countries like India as well. The main purpose of showing this slide is to just let the people understand that how the size of the car and the weight of the overall car is related to the CO2 emission. So if you see on the left hand side, the Japanese OEMs are quite good in that, because their cars are as compared to BMW or Daimler are quite light in weight. And as you go on a right hand side, the car gets more sturdy, but of course at the end of the day CO2 emission has also increased. And in the bottom they have mentioned that the size corresponds to the market share. That is also a fact. What is the approach? The approach could be, as I mentioned, to do the engine efficiency, to improve the engine efficiency. reduce the fuel consumption, but of course for that you need a specialized engine designers and other mechanical engineers. Another way, I think already many people have discussed, and you are going to see more and more of this, that aerodynamic performance. There are more and more aerodynamic shapes and bumpers and all those are designed nowadays to reduce the weight. Of course, alternative vehicle, that is battery vehicles or engine light electrical vehicles, but those are yet to be proven. There is still a lot of infrastructure need to be built for, particularly in a country like India, to use those cars. Again, exhaust emission, reduction in the exhaust emission, you need to have a very solid SCR and EGR systems to be implemented in the car. Alternate fuels, maybe bio-based diesel, petrol, and lastly the concept of weight reduction, which we are gonna cover. So this is just a chart where we can see that aerodynamic can result in the weight reduction by 10 to 12%. Metal replacement can also contribute in the reduction of weight by 10 to 20%. Replacement of metal and rubber could also be another area in the front panels and in the exterior. And lastly, the untouched area is the under bonnet chassis applications, where there is still a lot of scope for replacing metal, aluminium, and the metal tubings and rubber tubings. So what is a PA11 and PA12? As you know that PA12 and PA11 are most commonly referred to be very similar product. Yes, of course they are similar, but in the sense, in the nutshell, they are quite different, and both are how to offer in the renewable range. We do have a fine powders that can be used for the powder coatings, which are PA11 coming from a PA11 family. We do have a polyamide 11, which can be extruded, injection molding, blow molded by all melt extrusion process. Of course, we have a bio-based polyether based elastomers, and we do have a copolyamides and transparent nylon, which are also bio-based. Just to highlight you that castor plant does not compete with food crops. They are normally grown on the semi-dry soil conditions. And just for your information, Arkema is till today procuring more than 70% of its castor oil from India. So the castor oil is procured in India, taken back to France, and then produced in form of PA11. So still maybe the market may be PA11 may be very, very low in India, but some way India is contributing to what today we are producing our PA11. And virtually we could add more to it by using more of PA11. This is for just the references and what certification we have. We are the PA11 is already been certified as a biomass based by Japanese Organization of Recycling Association. We have a European bioplastic certification, and we are the 2006 bioplastic winner. This catalog shows the castor oil. It represents the bio-based plant. Coming back to standard automotive applications, I think many of us are known to this because these are the classic applications which have been there in the market for more than 50 years now. These are mainly fuel pumps, corrugated tubings, multi-layer tubings, then brake booster lines, air brake tubings, quick connectors, fuel lines. So these are the traditional areas where polyamide 11 is used. Of course, fine powder. Fine powder is also used in the field of automotive and many other applications. It is used for sliding door handles, spline shaft, and it is used all over the world, and we have many references for these applications. Now, what is our high temperature concept? In the in the next generation PA11 we have X series polyamide 11s which can be used up to the continuous usage temperature of 150. And then after that last year we are successfully developed and commercialized the new high temperature Rilsan, which is for the continuous usage of 175 200 with a peak of 220 225. So in the first generation, that is the X series of PA11, we have a polyamide 11 which can be used for the fuel lines and gasoline and diesel applications, and it has an excellent long thermal stability up to 150 degree continuous usage. As I mentioned that after this next generation PA11 we went further and we developed the new high temperature nylon which can be used for 150 plus.